All right, how's it going, everyone? Harsh, welcome. Yes, there definitely could be audio. I need to, I need to find some like music that matches the vibe. But when? There's no time. Yeah. So today we're going to continue domain modeling from last episodes. Hey, Philip. Hello. Yeah, so we're just gonna continue from last episode's domain modeling. Let's do a quick recap. I'll switch over to my screen. Wait, where are we now? The screen is frozen. Let me switch it up actually. There's gonna be a little loop, but hold on. There's a loop. There we go. Okay. OBS. I love it when it works. I hate it when it doesn't. All right, so let me show you what we did. In the previous episode, we went through this part right here, the process modeling. We defined all of the events and commands and systems, right? And we basically pulled out the entities and value objects that are present in, like these groups individually. So we ended up with something like this. We have the legend, we have the entity, value, object, and aggregate. We defined all of the aggregates and all of the nested entities and value objects. Okay, so by the end of the episode, we started to work on the skill value objects and also the aggregate roots, and that's when we needed to cut the stream because yeah, it was like 3.5 hours. So so we're just gonna continue from where we left off. We created the skill aggregate roots. We learned about aggregate roots and what their responsibilities are, what we should include in them, their rules, like immutability and stuff. And we created these two value objects, but as primitives. But we're going to circle back, do some refactoring. We're gonna do some refactoring because we created two files, one for the root aggregate and one for the entity. We don't need two, we just need one. So we're going to fix that real quick. And then I'm gonna talk about value objects and what they should be doing. Hold on, actually, I don't think I posted that we're live here. There we go. Now my Discord knows. Cool. Nice. All right, let's get into, of course, I need to share this link so you folks can follow along, and there we go, should show up. All right, here's the skill entity that we built. We first built like a base entity that all of our entities will extend from. And that's basically a simple class that only, includes an ID, right? The entities are identifiable, so it includes an ID. So we don't have to like do it for all of the, for all the entities. And we also extended or provided the equality operator and also the hash operator, right? So equality between two entities means if they're of the same instance and if their IDs are the same, right? So that's basically what entity is. And hash is just hashing the ID. That's basically it. Then we have the Aaron, welcome. Then we have the skill entity. We define the label and the aliases, and we started to define some of the methods. All right, so first thing that I'm gonna do is I'm gonna grab this whole thing, cut it, and move it to the skill aggregates. Okay, we don't need to. Why is the ID nullable? Because if we create an entity for the skill, we're not gonna have an ID until we, you know, put it into the database. So that's why it's nullable. Sai, hello. Thanks for joining. Hold on a second. I haven't posted everywhere. Yeah, let's bring some folks. Yeah, that was really fast. I just posted on a bunch of networks and forgot to post on the main ones. Okay. One Slack group and another Slack group, and now I'm happy. Let's get back to OBS. Yeah, that's why we set the ID as like nullable, just in case, you know, like we want to create a new skill. We're just going to like instantiate from the skill class. It's not going to have an ID until we, you know, pass it off to the command and to the repository to save it. In a lot of the DDD books, the ID is generated with a UID, but then you have issues trying to set that ID into the database when creating. No big deal. Yeah, that's also a good point. What is like the pros and cons? I was going to let the database, you know, create the ID for us, but this also makes sense. I've also noticed that, for example, when reading about entities and DDD, the IDs are usually UIDs, not in integers. What we're doing here is just like an auto-incrementing integer for the ID. I think that's like the base in in Python, in Django. But yeah, let me know if, you know, what's like the pros and cons, because I haven't worked that way before. I've always let the database define the ID, and then I'm gonna use that one throughout the application. But of course, it is so much different, you know. As long as the null doesn't leak out and your client code never needs to deal with the null case, then fine. Yeah. In the previous project, we utilized presenters in order to, you know, filter out all of the data that we don't want to leak to the client. Maybe we can like we could do some stuff like that in here as well. All right. Yeah. Basic equality to just check the instance type and of course the ID hash, and that's it. But now we're back at the aggregates. We do have the entities folder here and it's empty right now. So I'm just going to delete the whole thing. We don't need entities. And also the skill aggregates. This file, for example, when we are going to be importing this, it's going to be import from skill.domain.skill aggregate import skill. I'm just going to remove this and to aggregate underscore roots and keep this as like a consistent. We'll keep it at the top, not within a folder. I'm just gonna say aggregate roots.py, and inside we have skill. All of the applications, like all of the domain folders, not these, but like these, will have, I guess these are the aggregates, right? We can say that, but in Django. So they're all going to have a domain folder that have an aggregate root Python file, and that's where we export whatever the class of the aggregate roots. But we don't need to prefix it with the actual name, right? This is basically giving it up, but everything after this point is going to be the same. Let's see, I prefer UIDs over ID integers because it's easier to deal with in URL segments and things. I think the best practice is a flavor of UIDs called snowflakes, which can give you globally unique UIDs. Let's do some reading on them, because I haven't heard of snowflakes before. UUID snowflakes. The UID is like a standard 128-bit integer. That's pretty long. It's 32 character. globally unique without coordination between parties. They're generated based on the combination of timestamps, random numbers, and the unique MAC address of the machine. Collisions, they are extremely unlikely to collide due to their large space. Yeah, we're talking about 32 characters. That's a lot of permutations. For some applications, the 28-bit size, yeah, can be larger than necessary. Okay, let's check out the Snowflake IDs. Snowflake, it's like a 64. It's like more than half. Typically represented as a decimal number. Snowflake IDs are composed of a timestamp, a worker ID, a sequence number, and optionally a data center ID. Cool. Because it has a timestamp, there we go. It's never going to be like the same, right? Snowflake IDs are generated in a coordinated manner, ensuring within a given time window, a Snowflake ID will be unique. They're not designed to be globally unique, but rather unique within a specific context. They're highly unlikely to collide as long as the system is configured properly and the clock is synchronized. Yeah, like if we have a distributed system and their clocks are not synchronized, right? You have one server in Europe, one in USA. Yeah, I think that's what it means. Okay, so Snowflake IDs are well suited for scenarios where you need a unique identifier with a defined context within a specific application or service, and you want to generate IDs in a distributed, scalable, and ordered manner. They're definitely more compact, which can lead to storage. They're actually half, but I guess with the dashes in the UIDs, that's like 132. Otherwise, it's like 128. And processing efficiency. In summary, UIDs are designed to be global, for global uniqueness without coordination, while snowflakes are designed for uniqueness within the specific contexts. Hey, Digital, welcome. Just in time, yeah. Okay, so let's see. There is a Snowflake ID generator. I like that this is Python. You know, we just started learning Python, and now everything is Python. Beautiful. Okay, so we have a Snowflake ID generator, and this can be, of course, a service. We have the constructor here, which we pass a worker ID and an epoch. So we assign the worker ID, the epoch, the sequence, and the last timestamp. To get the timestamp, we're just using the time module minus the epoch. Generate ID. There's a timestamp. Oh, there's some like shifts going on. Look at that. Look at that. Interesting. Okay. I wish they included a sample Snowflake ID so we could see it, but interesting. Yeah, maybe this is what we want to do. That way we are going to have we're going to have an ID immediately after, immediately after creating the entity. And yeah. Auto incrementing integer. Yeah, that's what we have right now. UIDs were these, and now let's check out these snowflakes. No, these are space flakes now. They're not snowflakes. Space flakes are big numbers. We read that snowflakes are decimals, represented as decimals, but these are just big numbers. Okay. I guess we should give it a go, right? Snowflakes are useful for correlation IDs across services, where you want to be able to trace the activity of a given command across logs and services. Right, yeah. Like trace ID, right? Like a trace ID. In terms of like tracing. Nice. So, what do you think we should go with? Shall we try to do... We try to do like snowflakes instead of UIDs? Also, when we are... This is going to be an option. I mean, let's go back to the entity. This would not be nullable. It, for example, it will be string or whatever. It won't be nullable, but we can provide it. Because if we're reading from the database, we're gonna need to assign that ID to the entity before we return it from the repository, right? Here's what I'm referring to. Let me just find a blank space. Let's get up here, right? So we're gonna have like our application, right? And this is basically everything in our core logic. And there we're going to have a repository. There's our repository, right? You would create the ID in the entity constructor before saving it into the DB. Yeah. So the application communicates with the repository in order to save files to the database, right? There's our database here, whatever the database is, we don't care. Here's the database. There we go. But we don't want to work with database related types and objects here. That is contained within the repository, right? So I'm gonna remove this and I'm gonna do something like this. 2 arrows. This one's gonna be that way and this one's gonna be this way. When we want to save, we pass it an entity, and when we want to read, we also get an entity back. Right? We save and we pass an entity. We read, we get an entity back, the entity that we're creating. But inside of the repository, that entity, gets basically converted to a DB model with 2 arrows. There we go. So within the repository, this thing happens, right? The entity gets converted to a DB model and vice versa for reading. And when we do this, when we want to save, the entity is going to come with the pre-generated ID, right? It will be converted to a DB model and it will be passed on to the database. When we want to read the entity, the DB model will already contain the ID. So we need to make sure that the entity can accept assigning the ID manually, and it should not just by default generate the ID. That's what I'm saying. You would create the ID in the entity constructor before saving it to the DB. So the DB would not be responsible for creating the ID at all. I think the idea is that the entity should be a standalone object that the DB simply persists without doing anything else. What do you mean by that? A standalone object? Oh yeah, you mean like give me an entity and I'll put it into the database, etc. No generation, no like ID generation, no nothing. Yeah. Whereas in the DDD by the book would say you create the ID yourself in the entity. Yeah. Okay, let's do this. Let's modify the entity so we created ourselves, the ID we created ourselves, and also make it extendable so that when we read from the database, we actually assign the ID that's within the database. I'm just gonna leave this here. Okay, back to here. So the entity, the new entity, let's go back to Snowflake IDs. Here. There we go. There's the Snowflake ID. I hate that there's like no types here, but I bet it's going to be a number. Most likely an integer. So it's still gonna be an integer, but it's not going to, it's not gonna be nullable. Okay. So I'm going to make this not nullable. It's going to be an integer. We do have keywords only, so when we create this entity, we do need to pass, not this one, but like the extended entity. We do need to pass that. But let's think about this, because this is a data class. Maybe we do need to remove it as a data class and override the init method. So if we receive an ID, we'll just assign the ID to it. If not, then we're going to boot up the Snowflake ID generator. But that's going to be in the shared. It's not going to be in the domain. It's not a huge deal, but I've always wondered about this boundary between the entity and the database. I guess this avoids your system depending on the database infra layer to set the ID. Yeah, that's why I like it. Like everything happens in the application layer, like in the domain. I like that, not in the infra. All right, so we have a shared folder here, and we are going to be using this ID. We're not going to be sharing it across, like outside of the other apps. Most likely, it's just going to be used in the base entity because we have the base entity. So, should we contain this, or should we keep it as like a simple function, a simple class? It just generates the ID. If you look at like if we're following clean architecture, then this can be a service that, you know, exposes this generate ID, and yeah, let's actually do that. We're gonna do, if we put it as a service, that's still infra, so it's still gonna be infra. Let's see if we can turn this, keeps everything in the plain old objects. Yeah, which is one of my favorite things about a DDD. Yeah, I do like that aspect of it. Let's see if we can make this like a simple function. You know, not a class, so that it's gonna be like easier to. It's gonna be easier to, you know. We don't need to instantiate this. Why can't it be a value object? You know what? It should be a value object, right? Because it is a value, the ID, of course, but it's not a simple value to be treated as a primitive. It does have some behavior, it does have some validation and some generation, right? It's not gonna change, but yeah, let's actually create it as a value object. Okay, so inside domain we have the base entity. We're not going to scaffold this whole structure inside of the shared. We're just gonna keep it like flat. We're just going to do, actually we do need a value object here, and let's just say id.py, right? There's our ID class. There's gonna be an ID, and we need to do ID, which is going to be of type integer is with lowercase, integer, or where's my or? Ooh, okay. Was it here? There we go. Okay, interesting. Or none, right? We are going to have, we should have like a private generate, and I think we should prefix it with an underscore. Was that the syntax? Python class private method. Prefix it with Oh, 2 underscores. But you can use pseudo-private variables, like just 2 underscores, which means a pseudo-private. Okay, if it starts with pseudo, if it starts with dunder, we don't use it, basically, outside. Okay. Generate ID. And we're just going to generate the ID here, right? So if we don't get the ID here, right. I'm thinking like when we do the reading and we already have the ID from the database, we're just going to like assign it instead of generating it. That's what I was thinking. And within the, let's see, let me just connect this self generate ID. Otherwise, we're just going to say self.id is ID. God damn it. I'm just gonna return 1 for now, but we're gonna get back to this. Okay, so here's, for example, the ID value object, and what I was thinking to do is from like this, and this would be ID like this. Morning, Edward. Right, so we are using the value object now. We're not gonna be using any data classes. Well, we need to override the init, right? Because when we create the entity from the database, like after we read some data, when we convert the DB model into an entity, we are gonna have the ID. So we need to, like leave. We need to create a space where we can pass that database ID and just assign it instead of generating it. That's what I was thinking, and that's why I also accepted the ID here, which was like nullable. The property itself is never nullable, but the argument can be, just so we can like assign it. That's my approach. That's my approach there. Okay, so there's the init. There's gonna be like repetition here. There's the ID as well. Integer or none. And we just need to call super. Let's see. You might need a property to read the ID. Calling id.id to get the actual value from the object. Right, yeah. Property to read the ID. Calling ID to get the actual value from the object. Yeah, I'm gonna need like something like this, right? But in this case, we are gonna have the ID here, so I'm gonna need to rename this to like underscore ID and keep this as like uppercase. Was that the what you're referring to? Like a property for the ID. Let's figure it out. In this case, self.id is gonna be ID, and also the. Oh, you mean in entity? Right? Yeah. Yeah. To just like expose the value. Okay, so this ID will need to have an ID like this, or override the equality to be the same. The ID object, not the actual value. Yeah. Here's the situation. Let me just pass this. Here's the situation right here. We have self.id, right, which also contains ID, and now it's prefixed with an underscore. Self.id, and we can say dot other ID because that's the one we defined. So we either do this or we move the equality check. I think it's better if we do that. I think it's better if we just say equality here from typing import any. There we go. If we're talking about the same type, of course, ID. Yeah. And if self.id, but referring to the integer, not the class, is the same as the integer of the other ID, that would be the same. And now this will point to the actual value object, but the comparison between two value objects is going to happen based on the ID property, which is going to be the integer. There we go. Okay, so we have this. This is going to work. Hashing, we should also move the hash function, I believe, because we want to, you know, hash the integer, not the actual object. Okay, and then we have the generate ID. What's the following, like the postfix dunder mean? We read that the, you know, pseudo-private methods can be prefixed with a dunder, but what about the following? Or maybe we should just say generates. Yeah. Okay, there we go. So this can be nullable, the argument itself. You know, if it's not present, then we're just going to invoke the generate, so we get a new Snowflake ID. If it is present, that means we brought it from the database, then we just want to assign it. And here we want to call super, right? And we want to, actually we don't want to call super, we just want to say self.id equals ID and pass the ID through the, you know, in the argument. So yeah, this looks like it's hooked up correctly. The equality is based on the equality of the ID, which of course is based on the equality of the integer property, and also the hash itself. So, yeah. Yeah, okay, cool. Cool. If... Actually, let's go. We just need to do these things because this is the base entity, and when we go back to the aggregate root, for example, for the skill entity, we're not gonna need to do the equality or the hash. It's all gonna be correct here. Okay, now let's actually generate, you know, implement this, basically this thing right here. So we're gonna have the worker ID, the epoch, the sequence, and the timestamp, right? I'm gonna put this on one side, put this on the other, and make some space like this. Okay, let's bring in time as well, and we're gonna try to just, you know, put everything into one function, so we don't do like the Snowflake ID generator class. It's gonna be much simpler. Let's see. The epoch, I think, controls what is... Wait for next timestamp. The epoch controls like the phase. To me it looks like a little flag that we can like increment from time to time in order to avoid duplicates, right? Collisions. So if we start to see collisions, we can just increment the epoch, I guess. right? Maybe. So I have seen you write a ton of code for this project, do a bunch of research, but I have not seen you test anything in any kind of way. Have I missed all of that, or has there been none? None. How do you know it works? Right now we're just looking at code and like, you know, hoping that it works. How you would test the Python side? Oh, we'll just use PyTests. Literally. Yeah. We're just gonna use PyTests. We do need to write tests though. That's part of the, that's definitely part of the project. And I mean, now we are going to put some logic in, like generating the IDs, etc., etc. So we are going to need to put some tests down, right? Starting from this episode, because last episode, I think in the last 15 minutes maybe, or 10 to 15 minutes, that's when we actually created or wrote the first code. So we are going to begin, you know, testing. But yeah, this is going to be the first functionality. Not really, but the first like function that outputs something. And once we have this implemented, we can then test the hash or the equality, or, you know, creating two different IDs, making sure, you know, or create one with a specific ID and one without, so we can generate it, so we can, you know, make sure that that behavior is covered with tests. But we are gonna do that. Okay, here's what I'm gonna do. I'm going to copy this. I'm gonna copy this class. Actually, wait. Let's just like figure it out. We have a worker ID, an epoch, and a sequence. The sequence is 0. And every time we generate, oh, there, it is stateful, as you can see. So every time we generate an ID, we increment the sequence, you see? And if the sequence is 0, we wait for the next timestamp, so we can get the timestamp. Of course, that's if the timestamp is the last times. Otherwise, that's when we reset the sequence to 0. Okay. We set the last timestamp, and then the Snowflake ID is going to be a timestamp shifted by 22 bits. The worker ID, we have an end. That was like a logical end. We add this hex to it, and then we shifted 12 bits, and then we add this to the sequence. And there's an OR, and I've never learned how these work. I used to know them, but in the context of mathematics, but I've never tried, you know, shifting bits in JavaScript, right? And then we just return the snowflake. So this is basically how we generate the ID, but all of this is a mechanism that prevents us from, you know, generating, or basically from collision, because it's based on a timestamp. If at the same time we try to create two IDs at like literally the same time, that's why we have a timestamp and we also have a sequence. But I want to understand why. I want to understand basically what is the epoch and the sequence as well, and the worker ID. The worker ID should be just, yeah, it's gonna be like a constant number, because in our case it's one server, right? We don't need anything else. So I'm gonna go to the robot, to Mr. Robot, and let's create a new chat and ask it to explain what the epoch, worker ID, and sequence properties do in this class. And we'll just paste it. Some context. We have a Django application, not distributed, running on a WSGI, which means it's synchronous, it's not asynchronous. Maybe we'll change that, but we'll see. But that's important for the timestamp, right? And we need to generate Snowflake IDs for our database models. And it's Django, not Jago. Jagno. Django. Breakdown of properties in Snowflake ID generator. Epoch is the custom starting point in time in milliseconds. All generated IDs are based on timestamps relative to this epoch. It ensures the IDs generated by the Snowflake algorithm are smaller numbers by subtracting the epoch from the current timestamp. Right now, no, we need to make that decision. Whether we want to use Unicorn or we want to use Gunicorn, right? That was the WSGI. Right now, no, I think we're in just WSGI. It's not distributed, it's single threaded. We don't have anything special. And I think Gunicorn or Gunicorn, it supports workers, I believe. Right? It supports workers that can process requests in parallel. Like we can spin up, yeah, we can spin up like 3, 5, 10 workers. So they can handle 10, you know, concurrent requests. And if we take that route, the worker ID is literally going to be the worker ID that we get from the from Gunicorn. And if we do that, we need to find a way how to pass, you know, how to pass the worker ID. Workers are basically threads. Yeah. Yeah. So right now we don't have a worker. It's like it's fixed basically, right? It's just one. Okay, let's see. The epoch is a custom starting point in milliseconds. All generated IDs are based on the timestamps relative to this epoch. It ensures the IDs generated by the Snowflake algorithm are smaller numbers by subtracting the epoch from the current timestamp. If no epoch is provided, the default is 0, meaning timestamps will start from the Unix epoch, the default one, yeah, 1970, 1st of January. In practice, you can use a custom epoch to reduce the size of the IDs and avoid large timestamp values in the ID. From the Django controller, yeah, and that's gonna be wild. There's gonna be a lot of jumps, right? Like we're gonna have the route handler, the API route handler. Then we might have like a command. Then we might have like a, you know, within the command, it's probably gonna be like the, yeah, it's gonna need to jump at least 3 times because it's probably gonna be in the request or something like that. Yeah. So the worker ID is a unique identifier for the instance generating the Snowflake. Let's actually go back to the epoch. I think we can like say the epoch is gonna be like the date today, right? The 6th of December or 1st of December. We can do that. So that we generate smaller IDs basically. And I don't think we change the epoch as well. We'll just set it to today, 6th of December, 2024. We'll just set the epoch to today's timestamp, basically, so that we can trim everything down. Yeah. And we'll just keep that. There's going to be like a hard-coded value. Because if we change that, we're just going to generate a different set of Snowflake IDs. And if there are changes in the epoch, that means we're basically increasing the chances of collisions. Yeah. Okay, the worker ID is a unique identifier for the instance generating the Snowflake ID. In distributed systems, this ensures uniqueness across multiple workers or servers generating IDs simultaneously. in your Django WSGI setup, which is not distributed, and it just copied over the not distributed. See, it's like very weird. Django application not distributed, and it just copied over the not distributed part. I don't even think it knows that it's not distributed. Yeah, the worker ID can be a static value, 0, because all IDs are generated from a single server. Yeah. However, if you scale your application horizontally in the future, you would assign a unique worker ID to each worker on the server. We could even do like environment variables in this case. We could even do environment variables in this case, like if we want to spin up multiple Docker compose Docker containers, we would provide that environment variable for the specific, container instance, and we're going to use that as a worker ID. Or if, if we, as we mentioned with Aaron in the chat, if we use Unicorn, it's going to be, there's going to be like threads. We can get the thread ID and put it as the worker ID. So that's how we can ensure that, we're generating unique IDs. Cool. The sequence is a counter that ensures uniqueness within the same milliseconds. Oh, it's already on the environment variable. Cool. Cool. That's definitely going to work. Yeah. So the sequence is a counter that ensures uniqueness within the same millisecond. When multiple IDs are requested in the same millisecond, the sequence is incremented to differentiate them. The modular operation, and we see a module from 4096, ensures that the sequence stays within 12 bits, maximum value of 4095. If the sequence hits 96 in the same millisecond, the generator waits for the next millisecond. There we go. So that's the sequence. We can generate 4095 IDs within the same millisecond without having to wait for an additional millisecond. And if we need to wait for an additional millisecond, then we are just going to reset the sequence to 0. That's the mechanism. Okay, let's see the ID structure. It's a 64-bit integer, typically divided into 3 parts. The timestamp takes up 42 bits. It's relative to the epoch because we do the offset. Forms the most significant 42 bits. This ensures the IDs are time ordered. The worker ID is 10 bits. This allows up to 1024 unique workers. Damn, that is a lot. And then the AND 3FF mask ensures only the lower 10 bits of the worker ID are used. Right. So like if you, okay, I understand that. It was something like this if I remember. Yeah, let's just jam for a bit. Like let's say we have like a binary number, right? This is the binary number, and if we want to. And if we want to do like basically sum these two, and if we do this, right, this is the end. What we get would be, no, what? Come on now. Damn it. Awful. All right, line, I need a line here. What we get, beautiful, there we go. What we're going to get, and I'm gonna change these so they're not, let's do 0 here, 1 here, 1 here, 0 here. What we're going to get is a number that's basically this. We're gonna have all of these be zeros. There we go. All of these are gonna be zeros, even though the original number has ones. 1 plus 0. 1 plus 0 equals 1 or 0. Now here's what I'm blanking. if this says that we're using this mask to ensure only the lower 10 bits are used, that means only the lower bits are used. That means all of these are like zeros and the lower 10 bits are used, right? Was it like that? I haven't done this in like a decade. But yeah, if this is 1 and 1, this is 1, 0 and 1, 0, 1 and 0. Maybe I'm doing like a... Maybe this is the end, yeah. And it's gonna be like 0 here. And this is gonna be the final number. Maybe I'm blanking, I don't know. Binary math is fun, yeah. But I guess this is what we're doing, right? But instead of this, we have the 3FF mask. What we're doing is like we're selecting a number, like a number of bits. We do all of them as like zeros so that we can only take the last digits of this number, which is going to be this, and the rest of them are going to be like zeros. Yeah, I think like true and true is true and true and false is false. It's just like I think that was end. I don't know. Truth table PTSD right now. Yeah, but that I guess that's what we're doing here with the 0x3FF. It's basically a mask that is like zeros and ones, and you have like 10 bits of ones. The rest of them are zeros, and we apply that on the worker ID so that we only get the lower 10 bits. Yeah, close enough. And then we have the sequence, which is of course the incrementing number, so we can, you know, have the unique IDs per millisecond per worker. And this is the formula, the timestamp, the worker ID, and the sequence. So in a single worker scenario like we have right now, you can set a fixed worker ID, like a 0, as only one server instance in generating the IDs. But future proofing for scalability, if we ever move to distributed setup, like multiple WSGI. Randy, welcome! Like we have multiple WSGI workers, or you might even go to Unicorn and do ASGI scaling. Each worker can be assigned a unique worker ID, and as Aaron mentioned, we can pull that from the environment itself. Cool, I like this. I like this. For your use case recommendation, set a custom epoch like the start date of your project. That's what we're doing, right? Today. To reduce the size of the generated IDs, use a static worker ID for now, as your application is not distributed. In your Django models, you can use the generate ID methods for fields requiring unique ID. That's exactly what we're doing. Cool. So this is even like the epoch that we want to create as well. So I'm going to pull this as well. Nice. So let's go back to the code. And I guess everything is going to be contained within the generate class, right? We're going to have an epoch, and the epoch is going to be, actually, let me put the robot here on this side. The epoch is going to be this integer right here, but we're going to change the date. Keep the Snowflake class as a private class. Yeah, I'm thinking we'll just, you know, try to fit everything inside of the generate method. It's gonna be like a single method, basically. And we're gonna test the generate method on the ID itself, but not like a specific class. You mean we can keep the complexity in the Snowflake class? Can we have like a private class? Or is it still gonna be like an underscore prefixed class? Can we have private classes in Python? They're not true private. Probably, yeah, single leading underscore. Yeah. Double with name mangling. Yeah. Into the same ID pi. Yeah. Or like even within the ID class, like it's a nested one. Where was it? Yeah, like this. But no, we can just put it here. Snowflake ID generator. And might as well just like do the same thing, right? We have the init here. We're going to have the worker ID, which is going to be 0, and also the epoch. We're not gonna take the epoch. Not here. You know, it's just gonna be like hard-coded. Yeah, not to actually like a true private uncallable. It's just gonna be like prefixed with a dunder, so we know that we're not supposed to use this basically. Or like if it's nested within the ID, wouldn't that make it like uncallable as well, because we're not exporting it, or Python will export that as well? Curious to see if that's the case. All right, so we have the epoch, and it's going to be an integer. We have the worker ID, and that's going to be an integer as well. And we also have the sequence, which we initialize it at 0, but we're going to increment it to so we can like generate unique IDs within the same milliseconds. All right, now here we're going to do worker ID is equal to the worker ID, which is going to be 0. Damn, not class, but def. There we go. And now the epoch is going to be the thing that I copied, which is over here. And we're just going to change the date. Oh, it's an integer as well. We need to wrap this. There we go. Damn it. I need this whole thing. Maybe not without the last. No, copy it again. Yeah, without the last parentheses. There we go. And we need to do self.epoch equals this. So this is going to be 2024. It's going to be the month of December, the day of 6th, right? And we'll just, keep everything the same. Yeah, make time. And it's, yeah. Okay, so here's the epoch. And it's always going to be today at midnight, right? We're not gonna do the clock thingy. We're just gonna set the 6th of December, 2024. Everything is 0, midnight. That's the epoch. This is the start of our project. So all of the IDs are going to start from that timestamp, as if the time began now. That's the idea. Okay, so there's our init. We also need to define the generate method, right? And the generate method, let's go back to the class. The generate methods, yeah, there's no arguments to it. Now let's see. Oh, there's a timestamp as well. And that's going to be an integer. Or like by default, it's -1. Let's do that. Yeah, the start of the Lazar era. Right, self.timestamp is self.get timestamp. And we need to define that. If we need to get the timestamp, the get timestamp was just return, cast it to an integer, time.time, the current time, times 1000 minus the epoch. Yeah. Cinematic, hello. Welcome. Right, this is the timestamp. This is basically whatever is the time right now, and it's literally 10 sharp, 10 a.m., right? Minus this time. So it's going to say, it's just going to say 10 hours and 0 minutes and a few seconds right? If we were to trigger this now, it's not gonna say 2024 years, it's just gonna say 0 years, 0 months, 0 days, 10 hours, 000, and like a few seconds, and these are probably milliseconds. Yeah, that's the time, 10 hours instead of 2024 years. Okay, this is the timestamp. We got it right. And if the timestamp is the last, oh, there we go. Actually, this should be last timestamp, not the timestamp. So it'll give us a new timestamp, but if it's the same as the last timestamp that we generated, we need to do the thing. Yeah, that was fun. I had a pronunciation guide on the personal website. Now I see that the LinkedIn has like a little play button. Okay, so if the last timestamp is the same as the timestamp that we're dealing with right now, we need to increment the sequence. Self.sequence incremented by 1, but apply a module of 1496 because we don't want to go above 1495, and that was a bit limitation. 12 bits. Yeah, it has to be 12 bits, the sequence. Okay, but if the sequence is 0, right, and that's an if, that means if we're doing this for the first time, I believe, basically this is going to be the second ID within the timestamp. So we generate the first ID, right, and the last timestamp is going to be -1, so it's never going to be true. We're just going to generate it, and we're going to set the last timestamp to that one. But the second time we pass, in the same millisecond, we try to generate an ID. The sequence is going to be 0. This is going to be true, but the sequence is going to be 0. So this is for the seconds. So this is for the seconds. Wait for the next timestamp. Oh no, actually, it's 0. Oh, okay, it's not going to be the second. It's going to be for the 4096th generation, right? Because it's 0, but it's by default it's like 1. 0 is going to be when it resets. There we go. Okay, so we're talking about the first, of the next resets. If it's 0, then we need to wait for next timestamp. And we need to define that method as well. Wait for next timestamp. And I'm curious to see how we're going to define that. Timestamp equals self.get timestamp. And while the timestamp is less than or equal to the last timestamp, we just reassign it. We just reassign it. And we just return it. What's up with this now? Oh, there's no self. Yeah. Give me the timestamp. Are we still within the last timestamp? Right? Yeah. Wait for it until we're not. When we're not in the same timestamp, that's when we want to return that. And this is going to create a loop long enough for 1 millisecond to pass so that we can get out of this loop right here. Wait for the next timestamp. Otherwise, and that's going to be here. Come on now. Self.sequence. Oh, there we go. X is 0. Okay, so what does this mean? If the last timestamp is equal to the timestamp that we generated now for the new ID, right, this is going to happen. Otherwise, just keep the sequence always at 0, right? Just keep resetting the sequence at 0 until we request a timestamp, until we request an ID within the same millisecond, right? That's only then you can start incrementing this. Okay, yeah, sane mechanism. So we do this. We have the correct timestamp now with the sequence as well. So we want to set the last timestamp now to the current one. And then we just generate the Snowflake ID. Snowflake ID is going to be, okay, this, I'm going to try to type this out. It's going to be timestamp. We need a new parenthesis here. Shifted by 22. An OR operation. Evie, welcome. An OR operation. And then we're going to do the worker ID. We're going to apply that 0x3ff 10-bit mask. After we apply that, we're going to shift that to like 12 bits. This is in double. We're going to shift that. Actually, we did that. We did the shift. And we're just going to say the sequence and apply that same, it's not the same actually, 0xFFF. The sequence is how many bits? 24? 12 bits actually, 12 bits, yeah. Okay. Timestamp, where were we now? Here, and we just return it, right? Okay. Yeah. Joined right in time for the bitwise operations. Okay, this is it, right? This is the generate method. That's the algorithm. Cool. And now all we need to do is just don't do the epoch here. We just want to instantiate the Snowflake ID generator here. It can be instantiated without any arguments because the worker ID is always going to be 0. But we get to pass it. Might as well like set it to 0, right? By default. And check for the environment variable inside. I don't want to pass worker IDs. If we can do that with an environment variable, that's going to be perfect. Because that's what it needs to be. Cool. Now, here's the ID. When we say generate, we'll say generator equals dunder Snowflake ID generator self.id equals generator.generate. There we go. And we just need to, we don't even need to actually return anything, right? Oh, actually we do. Instead of self.id, we're going to say return generator generates. Yeah. Right, yeah. Hey Yaka, how's it going? Missed the start of the stream and I'm curious, is this approach to generating unique IDs correlated to DDD? Not directly to DDD, but like indirectly. We're generating the IDs not in the database, but in the domain layer within the entity, so that we take that responsibility out. And we always, when we create an entity, we're always going to have an ID, whether that's newly generated or read from the database. We shifted that responsibility to the entity and not the database. Let's do the worker ID as a constant here, and worker ID is just going to be worker ID. I'm gonna delete until, oh no, not until that, until this. Wait, what? Delete until, and I'm just gonna say this. There we go. We don't need to assign the worker ID. It's either gonna be 0 or we're gonna pull from the environment. But there we go. In here, we're just going to work with this worker ID. So there we. Okay. All right. Right? Yeah. Let's try the REPL now. Really want to see if I create an ID. I want to see what it's going to generate. Okay. Let's boot up the database just in case, because we have applied that migration. I can't really run the REPL here. And how did we run the REPL? Was it with like start server? It's not with start server. It was, I guess, just Python 3, right? Like right here. There's the REPL, and we can say from shared domain value objects ID, import the ID class, right? So if I say ID, and not pass any ID, it should trigger the generate methods. If I pass it, it should have that ID that we pass it to. Okay, so bam. Is missing one required positional argument. No. This is an optional one, right? Integer or none. Oh, all right. Yeah. We want this to be like keywords only. And this because it is a... Okay. How do we make this optional then? Integer or none. Avoid passing the ID until you need it. What do you mean? I'm asking the robot how to make the ID optional. Oh, equals to none. Okay. Because if you're storing entities with an ID, then you read it back from the DB. Why do you need to set the ID at all? Won't just be a read back from the DB? No, yeah, but like when we read it from the DB, we're reading models from the DB. That's like how I'm thinking about this. We're reading models from the DB and we're converting those models into entities. That means we're gonna need to like recreate the ID class and pass the ID. Yes, this is what we're missing basically. Okay, let's go back and let's do the ID now. Oh, maybe I need to close the REPL and do the thing again from shared domain value objects ID, import ID. And now let's try to instantiate an ID. Is not defined. Did you mean Snowflake? Oh, maybe this is like a... Maybe this is like a REPL thing. Oh yeah, I need to also bring in from shared domain value objects ID import Snowflake ID generator. And basic, I can do this now. Yeah, there we go. Nice. Thanks, Aaron. Avi says you can also inject something like an identity provider using UID as an implementation in the command handler. This way you decouple it and you have only one place to change later. That's a good point. Like, but still no. I mean, we're gonna have one. We're gonna have one class for the database model, and we're gonna have like a mapper that'll take a domain model. That'll take a database model and convert it to an entity, and that's why we're passing these IDs for when we read from the database. When we want to convert the database model to an entity, we actually pass the ID that comes from the database. But when we say create a skill, we're not going to pass any IDs because we're creating a new. So the generate method will be invoked. That's how I'm approaching this. But yeah, maybe we don't need to do this. We'll see at the end, basically. Okay, so let me also override the string. Damn it. When I write self, S is for option, and then E quits. See? I need to lift S before I press E. Otherwise, it's like option E, and that's you know, exits from the insert mode. Okay, I believe I'm doing this correctly. Oh, it's not the ID actually. Right. Wait, hold on a second. This is not, yeah. What did we do here? We invoke the, damn it. Okay, we should do generate. Just generate, yes, generate. There we go. There's one, there's two. You see the IDs? There we go. Yeah, tap times are too low. I need to figure that out. The tap time right now is set to like 165. Maybe I do need to set it to like default. 200. Let's try that then. Let's bring it back to default. Let's bring it back to default and install it to the keyboard. Flashing. Cue elevator music. Okay, I really love this tool, by the way. Bam. Okay, let's test it out now. Go here. There we go. Much better. Yeah. End stream, keyboard broken. Keyboard bricked. Okay, so we have this. Thanks, Aaron. We have this, and we have this. So there's our IDs, basically. We're just gonna generate these kinds of IDs. And I'm not that fast, but like we can write some unit tests for this, but yeah. We can write some unit tests to see if I'm not sure how we can see that, but like if, for example, the sequence incrementing works, if the wait for the next timestamp works. It is annoying to choose the keyboard from the list, yeah. But I guess it's like you gotta press the reset button on the keyboard, right? To activate that mode. Who knows? All right, I have no clue how we can test this, but Let's see. I don't know if this has to be testable, but yeah. Okay, now we have the ID class, right? And we can do, where's ID? How many times did I press this? Damn it. From shared domain value objects ID import ID. If I just do ID like this, damn it. And it's inside of the ID. This might be the REPL thingy. Is not defined, did you mean? ID Snowflake ID generator is not defined, did you mean Snowflake ID? Yeah, I think this is just REPL messing up. Because it has like two classes in the same file. Okay then, let's create like a utilities folder and just put this in the utilities. I would test it by checking the output shape. Maybe somehow verify it's like a 64-bit integer. I wouldn't try to test its uniqueness. Yeah. Yeah. I think we can do that. Or like, you know, do a range from 0 to 10 and, you know, try to generate 10 IDs within the same millisecond using a range, or I don't know. We'll see. We'll see. But I'm gonna create utils snowflake id.py. I'm gonna create this file and I'm just gonna move the snowflake class. We're using basically all of these. I'm just gonna cut this, move at the bottom. We don't need the typing, and this is not going to be done there. It's just gonna be Snowflake ID generator. We don't need this. We don't need the whole generator now. We're just going to import it from shared utils Snowflake ID import Snowflake generator. Yeah, it's not gonna be private, but let's just say YOLO. There's a generator. Okay, now we're happy. Close this, go back. Oh, create a new thingy, city into the apps and then API. Activate the virtual environment again because I closed the Tmux window. And now Python 3 from shared domain value objects ID import capital ID. And now if I try to run this without, there we go, we have the ID and it doesn't have a string. Oh, what is this now? Snowflake. There we go. These are all like different IDs. Oh damn it, I forgot the curly. Yeah, it doesn't have like a string method, so let's do that as well. But these print out the ID. Yeah, that's it basically. I need to do this again then, right? Import ID and then just print out this ID. There we go. You see? And now we're using the ID value object, not the Snowflake class. So these are our IDs basically. Very nice. Very nice. ID is done. And I didn't, you know, pass. I didn't pass the ID, but what if I do? What if I do 1, 2, 3, 4, 5, 6, 7, 8, 9? See? Now it's that ID. If I don't pass an ID, I'm creating a new then it's going to generate that for us. Beautiful. This is the behavior that we want to see, right? Okay. This is it. This is it. We are happy. We're very happy. So yeah, the entity receives an integer, right? That's either going to be from the database or it's just going to be none. And I need to make this optional as well. So on the type itself does not define whether the argument is optional. Now it is optional. By default, it's going to be none, right? So when we pass it off to ID, if it's, you know, if it doesn't exist, if it hasn't been passed, then generate it. Otherwise, just use whatever, you know, you got from the outside. Same as for the entity. Yeah. Yeah. That's about it. That's about it. So I think, what was that? I think we're ready to go back to the skill, right? Here's our entity. We're going to convert the aliases to a value object as well, because they have some, you know, they have some behavior around them. And we're also going to split the, like the implementation outside of the skill aggregate roots. We have value objects here, but we don't have anything inside, so we're going to create the aliases as a value object there. But so far so good, I think. Let's try this then. I'm gonna go back to the REPL, but I'm going to import it from skill domain PyTest. Yeah, I do have PyTest requirements. There we go. We just need to set this up. From skill domain, aggregate root import skill. Ooh, look at that. If that name is import skill, false, keyword only true. Where's this? This is coming from the data class, right? Yeah, it's coming from the data classes. Like this is mutable default for field alias is not allowed. Use default factory. Mutable default list for field aliases is not allowed. All right, so that's maybe this is the case for the aliases, right? For that field is not allowed. Okay, we are going to convert this into a value object for now. So I'm just going to do this basically. Right, I just need a label. And since it's a data class, well, I need to close REPL, re-enter it, import it. Yeah, now the import works. Now, if I print, and we're gonna need the string method again. And we're gonna return not these, not these, these. There we go. We're gonna return skill and then self.label and then ID equals and then pass the ID as well, right? Okay, close REPL, re-enter it, import skill, and if I print the skill and the label is going to be HeyStream, we should see HeyStream as a label, but then also the ID of the Snowflake ID. Bam. No. Skill object has no attribute ID. What do you mean? We do extend from entity. and it has an ID. Right? Keyboard. There's a label. There's the ID. Hey, Gabriel. Welcome. Yeah, I think this is just the... I think this is the... do we need to call super? Dude, yes. We do need to call super, right? I mean, I thought data class would have done that. But maybe we do. Maybe we do need to pass. Let's bring in the robots. I have an entity that's a data class that extends the base entity class, which defines the ID. When trying to print the... I'm gonna be here, skill entity, that is a data class. It throws an error claiming ID is not in init. There is no init. Why don't you use the Copilot chat? All right, yeah. Actually, yeah, let's try that. I'm not gonna do this, but here, creating an instance of the skill class and printing it throws an error claiming that self.id on line. I have no idea what line is that. 26 actually. On line 26 does not exist, even though we extend the base entity class which defines it. What could be the problem, sir? We need to call super. Well, why do we have a data class in that case if we need to call super then, right? What's the point with data classes? In that case. It is annoying. Alright, so here's the ID. Either integer or none, and by default is gonna be none. Label is gonna be a string, and aliases is going to be a list of strings. Might as well just remove the data class. And by default it's gonna be like an empty array. And now we'll say super init, and we can pass in the ID that we have. And then of course self dot label is gonna be the label, and self dot... We don't have aliases yet. I'm gonna keep it here. What's up with this? Oh yeah, parameter without a default cannot follow. So label needs to come first because the ID is optional. The aliases is optional. Label is the only thing that's not optional. So I'm gonna cut it out and place it here. And now it's happy. Yeah, let's ask the robot, why do we use the data class if we need to explicitly define the dunder init method then? Yeah, that's the benefit. Using the data class decorator provides several methods. Okay, let's wait up. Okay, cool. Let's do some reading now. Using the data class decorator provides several benefits, even if you explicitly need to define the dunder init. Some of these include automatic generation of other methods like the REPL and the hash if applicable, but we said equality and hash should not happen. No, we disabled that here, equality equals false. We set keywords arguments only, and we also need to add one for the hash because we want to use the hash definition from the entity and not from the, not from the data class. Field definition, decorator allows you to define fields in a concise way. Immutability, you can easily create immutable data classes by setting frozen to true. However, if you need to customize the init method to handle inheritance or to perform additional, the data class decorator does not prevent you from doing so. Yeah. Oh, there's an optional from typing as well. Yeah, just apart from setting the properties, but we still set the properties, right? Might as well just say, like, don't use it. In this example, the data class decorator is used to define the fields and their types, while the custom init method handles the initialization logic, including calling the base class's init method. Yeah, look, we have equality set to false, but we're also gonna need to set the hash to false if this is the name of the argument. No, it's not. How do we... Yeah. Yep. No data classes. That's it. Just do it the plain old Python way. Yeah. Refactor to data classes later. Yeah. But it also like makes sense, you know. In this case, everything is provided here. Here's the equality. Here's the hash. I don't know what the REPL thingy was. Let's ask the robot. What's under REPL? Is that for like the REPL or representation of the objects? Something about representation. This representation is intended to be unambiguous and useful for debugging. When you call representation on an object or when you print an object in an interactive session, Python uses the REPL. Yeah, that's true. We should avoid using data classes since we're learning Python. Yeah, and REPL is just like the str, but it helps in testing. Right. Okay, cool. Cool. We have the str, but actually I can do REPL and it's gonna be the same, right? There's the skill, there's the ID. That's all we need. And of course the aliases when we define them. But so far, if I go back now, re-enter the REPL, import skill and print out hey stream, there we go. Skill hey stream ID is set to that. Beautiful. I can even like add like escaped quotes. There we go. Python 3, import skill, print it out. There we go. Skill, hey stream, ID is that. Nice. There we go. I like that. Okay, so this looks right. We're generating unique IDs. If we pass an ID to skill, let's actually try that because we haven't tried that. We did that import skill, but we'll say ID equals 123, just 123, and the label is that. There we go. You see that? The ID is 123. But if we don't provide it, that's when the Snowflake algorithm will kick in and it'll just give us an ID. But we're always gonna have an ID. Yeah, string is for user and representation is for developers. Right, yeah. Like if we just want to take a class and like convert it to a string and show it on the UI for a user, then yeah, that's the str. We're just gonna use the representation because we don't plan to, you know, print this out. But maybe we will, because we do plan on implementing a presenter pattern. So we might as well implement this as well. We'll see. So far, so good. I'm actually going to push everything here. Some refactoring, really bad message. Some refactoring plus Snowflake ID generation. There we go. Nice. The next thing that we want to do is refactor aliases to be a value object. Yeah, the view model presenter thing will actually handle that stuff. All right, next thing to do, get into the value objects. Right now it's like an empty, it's an empty folder, but we're gonna create aliases.py, and we're going to create that value object here for the aliases. Actually, yeah, let's first from shared domain value objects. We don't have a base value object. That's what we actually need to work on. We do have the ID, but no base value object, right? Oh. Isn't IDs auto-generated in a DB, or if it's primary key, then why do this? I didn't get it because I joined late. Yeah, we're not gonna auto-generate them. They can still be primary keys, but they're not gonna have like a constraint to generate them. Yeah, the value object should not need an ID. It should just implement the equality and hash methods. Yeah. So we just need to round up all of the properties, calculate their hashes, and like mush them together, right? There we go. Value objects. There's not gonna be any init. I don't think so. There's gonna be an equality check with the self and the other. So that's what data classes do. Yeah. Yeah, they do the equality and the hash. Well, we are actually going to implement it ourselves here. So in here, what's this? Oh yeah, from typing import any. Incompatible matter. It's cool. It's cool because we have pass and we don't return anything. Our IDs are value objects, but they're just classes. They don't extend the value object here like this. And we do have the equality and hash in them, but we shouldn't have implemented this. See, this one is specifically for the ID, but we don't want to implement the equality and hash for like every value object that we create. So I'm just going to go through, I'm going to do this basically. Yeah, let's just copy this, paste it here, but they're not going to be like self.id because we don't know. We just want to get all of the properties and like match it against the other. Yeah, so these, I'm simply going to delete them. And I'm just going to do from shared domain value object base value object import value object, and I'm going to have the ID extend the value object so that we get the hash. And can you read the dictionary of the properties in Python? I'm not sure. We're gonna figure that out. We're gonna figure it out. If this was JavaScript, we need to do reflection. We need to use the reflection API to gain like access to the properties, but we'll see what happens in Python. Okay, first order of business, figure out how we can get these properties. So let's boot up this robot, the built-in robot, and we're gonna ask it to a value object is a base class that other classes extend and define their own properties. In this class though, we need to implement the EQ and hash methods that use the derived classes properties. How do I gain access to the derived classes properties? I know you can't see this, but we'll look at the answer. Okay. To implement the equality and hash methods in the value object base class and use the derived classes properties, you can use Python's getAttribute function to dynamically access the properties of the derived class. This approach allows you to compare and hash objects based on their properties without knowing them in advance. Beautiful, that's what we're actually trying to do. Yeah. So we need to do getAttribute self.attribute equals to getAttribute other attribute for every attribute in the self.dict. Basically, objects in Python apparently have this dict dictionary property that holds the attributes. There we go. No reflection. It's already there. Yeah. And if it doesn't even exist, right? Okay. It's claiming that it works. So let me actually scroll down a little bit below. We have the derived value object, which is a value object. It has an ID and name. Same ID and same name, right? When we compare these two, the first and the second, it's true. The first and the third, it's true. The hash, of course, just gonna print out the hash. Yeah. Okay, this is basically what we need. There's a dict object that holds all of the attributes or properties. Attributes. Get attributes. Okay. Okay, so in here, actually this is good, and then we need to return all, and all is a function that takes in probably expressions that evaluate to a boolean, and if all of them are true, then it's true. Now we need to use the getAttribute function on the self, or like on the left side of the equation, on this one, to get the attribute and compare it to the same attribute that's on the right side. And the attribute is going to be every attribute in the self.dunder_dict method property. Yeah, like array.every in TypeScript, JavaScript. Okay, so yeah, I've learned that it's easier for me to read expressions from the right to left, because I need to define what I'm working with first and then get into the expression itself. Maybe that's like that's how, you know, they should be read. But for every attribute in the dictionary object, for every attribute with this name, we're going to get that attribute from the left side of the equation and compare it against the value of the same attribute on the right side of the equation. So left.id equals right.id, left.name equals right.name. Cool. All right, that's it. And for the hash, we're basically going to do pretty much the same, I guess, but we're basically doing a tuple. A tuple of all of the... Can get hard to read in Python. Yeah, like right to left. It's easier for me to do right to left. Introduce variables or names or whatever it is. Introduce the names first and then read the actual algorithm or the actual expression. Cool. Now we're keeping these as a tuple. How do... Because the hash needs to be a string, right? Oh, we're hashing only the tuple. Well, that's gonna work, right? Let's go back to the REPL. Oh, okay, we're already in the REPL. I'm going to do a tuple of 1, 2, 3, 4. What? Expected most one argument but got 4. Oh, it needs to be an array, most likely. There it is. So let's say that these are like the values, and if I just do hash, it's going to be a string. It's going to be always the same, right? Because it's the same values. Yeah, a list. If I do 5, it's gonna be different. If I bring it back to 4, it's gonna be the same as before. 7, 9, 2. Cool. Yeah. That works. That works definitely. So we're going to hash, creating a tuple. We're going to create a tuple. Let's actually try. For every attribute in self.dictionary, do the self.attribute, get the attribute value and create a tuple out of all of them and then hash that tuple. All right, I think this is our value object, right? We don't have an ID, therefore the equality is based on the properties and their values, but not on the ID. Whereas the equality operator in the entity is just taking the ID and comparing the ID regardless of the values. Nice. Thank you, Mr. Robot. Now we have the base value object, and the ID that we created for the entity is actually a value object, so the equality is just going to exist in there. Jump around in insert mode. Ah, you mean like go to insert mode and do this? Yeah, I'm sorry, Prime. Very sorry, Prime. All right, there's our value object. Base value object, import value object. There we go. Because the aliases do not have an ID, they're literally a list of strings. We're gonna compare them with the value object, basically for every property. Now, we need the aliases inside, and that's going to be typing import list. It's going to be a list of string. We need a space here. There we go. There's our aliases, right? And we need to create the constructor first, and just basically have aliases, like have a list of them. As an optional, because we might need to create. Actually, it's not going to be an optional, right? If we want to create it, then it's going to be an empty. If we want to create a new skill with no aliases, just provide the label. The skills argument is going to be optional, but when we instantiate an aliases, when we do an aliases instance, that's just going to be like an empty strings. But the value object itself, the aliases will actually will force us to provide the list, because that's the actual value. Hey Abhishek, how's it going? You can use list instead of list if you're using one of the latest. I do, yeah. Okay, so this is like an older thing, right? I know that we have lists here and we have list in the typing still in Python, but yeah, thanks for the clarification, Patrick. All right, so there's our inits, and we do have a list of aliases. Wait a minute, now this should be lowercase. There's our init aliases. All we need to do is just assign it. Assign it to the self.aliases equals aliases. Now, assignment of lists in Python. Pass by value or pass by reference. Do I need to use like a copy on this list to fill up the value objects data, or this is fine in Python? Let me know. In the meantime, I'm gonna go back to the aggregate root here, and I'm basically gonna do the add and remove methods. But let me know if I should use like a copy method to copy over the list instead of directly assigning it, because I don't know if it's by reference. Yeah, so we do need to copy it because this is a value object. If we just assign it to the same reference, that means we can change the aliases list without using these methods, because we do have the reference. So we need to copy. Yeah, we need to copy this first. Let's go back and robot, wake up. How do I copy the aliases list from the argument to the self.aliases without keeping its reference? There has to be like a copy method built in, I assume, aliases.copy. Okay. So there's like literally list.copy method. Creates a shallow copy of the lists. Yeah. Same elements, but not the same reference. Beautiful. Yeah, so dot copy. That's what we need here. Beautiful. Give me a second. I ordered something really cool, and I asked my wife to go to the concierge down to pick it up. So I'm gonna show it to you later. Really, really, really cool thing. All right, we are copying the list, and we'll make sure that, you know, we don't just pass the reference, because value objects must be immutable, right? We create them with some default data, but from that point on, we have to use the methods that the value object is going to define in order to mutate the data, right? So we are going to define add here, and we're going to have a new alias, which is going to be a string. And what we're going to do is self.aliases.append or push. Append alias. There we go. But first we need to make sure that, you know, it doesn't exist. It does not exist. And when we do this, what if we manually pass, hey, a list of 3 strings, all of them are the same, all of them are hey. When we actually inject this into the aliases, we want to create a set first. So we remove the duplicates and then assign, you know, copy over that list and put it into the, okay, so I believe it was set like this. No. like this. Nice. There are sets. So we want to create a set out of the argument aliases. So we get all of the duplicates out, but then we just need the list. We don't need the copy, right? Because if we invoke the list and pass it some values, that the reference is broken here. We're not gonna need to do the copy because this is basically like 3. Why not keep it as a set? Yeah, let's keep it as a set, right? Yeah. They have to be unique anyways. Yeah. So the alias is a set and there's no append on sets now. There's pop. There's add. And there's also remove, which is going to be pretty cool. Yeah, we don't need the copy because we are taking in a list of strings, which is going to be usually going to be like from the database, right? It's going to be from the database. It's going to be a list, but we are going to keep everything as a set inside. See, this is that core reason why value objects exist and why we're moving the aliases to be a value object instead of just a list of strings like we had here, right? Because of that difference, like the database returns a list and that's it. You know, whatever's inside, I'm just gonna return it, for example, right? But or it's usually gonna be like a text, either comma separated or something like that. We need to see how we're going to keep the aliases. But yeah, they're going to be most likely a string that have some delimiter between them, and that's how we're going to keep it in the database. So when we get that out, we're going to split based on the delimiter that we define, and that's going to give us a list, right? And when we instantiate the aliases, we're going to pass that list, but from that point on, we're going to work with sets because removing duplicates is free. That's it. And that's why we keep this as a value object. We're going to define the add and remove methods, and we're going to feed it a list. But yeah, cool, nice. We might even we could even create the string method that does that delimiter, putting it all into a string that's ready-made for the database. So when we want to save it to the database, we'll just, save it as a string. We'll just, do string, pass in the aliases, and the aliases themselves are going to define that delimiter, whether there's like a percentage sign, a hashtag, I don't know. We'll figure it out. Yeah, cool. Look at that. Look at that. Do we need to throw any errors, value errors? Well, of course, yeah. We define an alias and it's a string, but we need to do runtime checks if the alias does not exist or the alias is not a string. We need to raise a value, wrong key, a value error, and we're just going to say alias must be a non-empty string. Okay, first validation. If aliases, self.aliases, or we do have the match. Okay, yeah, let's do the match. Self.match alias, that means if it exists, that's what the match thing is. But do we actually need that? No, not in this case, because we're only talking about the aliases. We're just going to say if alias in self.aliases if it already exists. I know we're using sets, but this is just for the should we actually throw a value error? Like if we say add this alias and it's already in there, we don't need to throw an error. The outcome is exactly how we expected, so we're not gonna do like a we won't do that. Yeah. What is this now? Oh, not actually. Yeah, if there's no value, or if it's not a string when we pass here, that's when we want to raise the error. Otherwise, yeah, just add it. Now let's try to remove this alias. Again, I guess the same validation applies here. If we try to remove an integer from the aliases, well, you know, can't push an integer into the aliases. Woohoo! Thank you, my dear. Nice. All right. In that case, we'll just say self. Oh. Remove, and we'll just pass the alias, right? Again, we're not going to check if the alias exists before we remove it. We're just going to invoke the remove, because if it existed and we remove it, it's not going to be there. If it didn't exist in the first place, it's already not there. But both of the outcomes are what we expect after we invoke the remove. So I don't think we need to raise a value error unless we come to like a use case, a scenario where we actually need, you know, to do that. But yeah, basically add and remove should not be raising any issues if the result is what we want, regardless if an actual removal happened or not, you know. Cool, we have add and remove. What else should we do now? That's pretty much it, actually. Yeah. And of course the string, so that we can just use this, you know, to save it in the database. Oh, maybe we can even create a static method on the aliases class that instead of a list, it takes in a string. It tries to, you know, split it based on the delimiter that's going to be defined as a constant here, and you know, call the init with that list, basically. That's gonna be fun. Yeah. Okay, so we need a delimiter. Just need to pass this. Let's do this real quick, and then I'm gonna show you the new thing that I got. And we need the delimiter. I'm gonna prefix it with a dunder just so we know that it's not supposed to, you know, get out there. Or actually, you know, yeah. Delimiter. It is literally going to be like a string, and let's figure out what is the safest character that we can use. A dunder. There are no double underscores in like natural language, right? Yeah, you can use a dunder for the delimiter. Because these aliases, they're gonna be aliases on the skills. We're talking about React, Terraform, C++. So that means plus cannot be a delimiter, right? There could be underscores on a specific technology. There could be even dunders for what, you know. So I don't know. What is the safest? Or a percent sign, like a double percent, something like that. Let me know what you think. If you've seen something like this, like what is this, or if you've read something like what is the safest delimiter that we can use for like natural language. It says the robots, but I'm gonna ask these robots. What's the safest delimiter we can use to split, I'm gonna say natural language text, right? To split a string into a string of natural technologies. Yeah, let's be super, and programming languages and other programming concepts, I would say. Professional concepts. Join and split a string of technologies and programming languages and other professional concepts without messing with its values. Let's see. Highly unlikely to appear. That's what we're talking about. Yeah. What is that? Oh, emojis. Or sequences like triple pipes or triple tildes. Yeah. But the bigger that the bigger the delimiter is gonna be, the value, the heavier the value is going to be as well. Dumb things as CSV2. Yeah, but I'm thinking like, what if a comma appears, you know, in a skill? Because it's not about just programming languages and stuff. It can be like literal words, you know, content creation, comma, blogging, comma, you know. So I feel like we need that, so we're gonna stay away from the commas. Maybe like a triple pipe will make sense, or a double pipe. A double pipe is or a triple pipe. I haven't seen a triple pipe. The x00, the null character. Yeah, but what if the hottest new JavaScript startup is called x00, a null character, and people start to learn their technology and add it? Yeah, let's look like triple pipe. I feel like triple pipe is going to be like safe enough. If not, it's gonna cause bugs. So we're just gonna let the users tell us that, you know, their skills are behaving weirdly. Okay, so there we go. What we want to do now is return a join, right? There's a join. No, there's a self aliases. It's a set dot join. Is there a join on the set? No. Let's see, how do we... Yeah, you can do that and then we'll see what happens. Intersection. Help robot, how do I join all the values of a string set with a specific delimiter? Delimiter. It's backwards, right? Delimiter the join and then a... Damn. Okay. Does make sense though, right? Self delimiter join self aliases. Yeah. Cool, and we get to define this here. And now we need a static method. It's confusing to use both Python and JS. It's like an interesting or not so interesting context switch. Okay, there's our string. So we use this method to basically convert the aliases into a database-friendly value that we can just use it as a string, right? We can store it as a string. But now we need a static method that's like an extension or an alternative constructor. I think that's the right name for it, an alternative constructor. That's basically, instead of taking a list of strings, it's going to take in just a string, right? And then we're going to cut it up with the delimiter and just create the set out of it. So let's see. Static methods in a Python class. I'm just gonna be like static method in a Python class. There is a static method decorator. Cool, that's basically what we need to read. At static method def from string. There's no self in static methods. There's going to be the value as a string, right? And what we need to do now is do aliases equals value dot split, and we'll just pass self. There is no self. So in that case, this probably needs to, I think it needs to go as a constant here. Yeah, it's probably gonna need to go as a constant, but I'm going to make this as like a lowercase. There we go. Evie, why preparing everything up front in aliases? Why not creating one feature at a time and let emerge the aggregates, entities, and value objects? They are details of implementation that evolve over time. We did the aliases under the. Oh right. Oh right. You can use a class method in this case. Yeah, let's do that. But to go back to Evie's message. I don't know, we did this exercise where we thought about all the features and the user flows, and we basically got all of the value objects already. So we just started implementing it, and we picked the tiniest aggregate to implement because this is the first aggregate that we're going to implement, like ever, to me personally. So I just wanted to get my feet wet with something smaller, but I can, you know, build things up. Yeah, maybe this is not the right way to, you know, start a project or start a DDD project. But yeah, that's what we're doing. I bet, you know, there's gonna be a lot of refactoring down the road as well. Okay, let's bring this back then. I'm going to, there we go. And this is going to be self.delimiter. And in here we can do aliases and then visual invert and then apply this. There we go. So these are the aliases. This is going to be a list of strings. And now what we need to do is return aliases, and we're going to pass the aliases, right? There's that list that we need. So we have both of these now. Beautiful. Just beautiful. And we have add and remove. I don't know if we need like a clear. If we do, we'll go back to it and implement it. But so far so good, right? So far so good. And now to wrap everything up, I'm going to create the aliases here and actually bring in from shared domain. Oh, it's not shared. It's skill domain value objects and aliases, import aliases. There we go. Here's our aliases. If we want to define aliases from a list of strings, we can. How do we do this now? Because we have the from string static method that uses a delimiter, and if we create a new skill, we're just gonna pass like an empty string or list, whatever it is, it's gonna be empty. But if we oh, hold on a second, CLS static methods, CLS, I don't think we're done here. Is this the correct way to pull this? I guess it is, right? Because Elton mentioned CLS, and I know there's like a CLS that we can get. All right, let me know if I need to pull in that CLS. I've seen this somewhere. Let me know if I need to pull that class method, as Elton mentioned. Oh, with class. So what's the difference between static method and class method? Is more correct because it works for subclasses. Okay, then let's do that. This is going to be a class method. So we're going to get the class, and we'll basically just going to do cls.delimiter, right? And this is basically going to, yeah, like this. Cool. So there's the aliases. Let's think about how we can. Oh, hold on a second now. Shall we do this as well, because we do have the class? With from string cls value string returns self. Oh yeah, I mean this is going to self an alias. Yeah, the type is inferred, but if I do just self, is the type. Oh yeah, look at that. Pyrite self is not defined, of course, with lowercase s. Oh no, it is a type probably. Well, we probably need to bring it in from types, right? Yeah, I'm just gonna let it. If it's fine, I'm just gonna, yeah. Pyrite infers it, my py doesn't. Yeah, I do have pyrite, I think. Yeah, you don't see it here, but let me actually show it to you. Look in the bottom. At least that's how I see that I have pyrite set up, but maybe something's wrong with my implementation. Doesn't matter. I'm just gonna leave it infer the type, if that's okay. If that's okay. If it's not the same, then look into it. All right, aliases now. The label is just a string. We'll just, you know, add it there, and that's it. And because it's a primitive, it's probably a copy, so we don't need to like copy the string, right? Pass it a string, that's it. Unless it's a reference. So let me know. But the aliases, should we receive them as a list of strings, or receive them as a string? Because that's the thing. If, for example, we do have the from string class method, right? There's another thing. When we receive aliases, when we receive value objects in arguments of entities, should we receive them in their own class, like aliases? These should be of type, the arguments should be of type aliases, so we create them outside, right? That should be the case, right? Instead of setting the type here, a list or whatever, I don't know, we should just make this an aliases, so we can create that from the outside, not like scaffold the whole thing, right? Aliases, And by default, I'm just going to create a new like this. So by default, the list is going to be an empty list, but it's still going to be a list. And if we don't provide an aliases through the arguments, we're just going to like instantiate a new aliases object, and that's it. And now all we need to do is self.aliases equals aliases. But when and we'll just we're gonna keep these, but yeah, don't do that. Okay, so it's not good in DDD. That's what I'm saying. Like, what is the rule here in domain-driven design? For example, when we need to do the like instantiate the skill, but the skill also has some value objects inside. Should we only create the list once? Okay, I guess it's gonna be fine. Yeah. Okay, we were basically gonna create the aliases outside, and that's when we are going to pass it to the skill. The default value, like this one. Yeah, I'm curious to like what happens in DDD. Like, if there is a rule in domain-driven design that's, or a rule, yeah, that, you know, dictates whether the ID should be the value object ID or should it be like an integer. That's what I'm saying. Let's ask the robot. I'm gonna use this robot instead. In DDD, where we have an entity class that accepts data for a value object, should we receive it as a primitive type or as the value object class? I have a skill class that accepts a list of strings that contains, not accepts. We don't know what we should accept. Contains a list of strings in a form of a value object called aliases. Should the aliases argument in the entity constructor be a list of strings or the aliases class? Let's see if there is a rule for this. You should prefer passing value objects, not primitives. So that means we need to get the ID as well, right? Encapsulation of behavior and invariance. By using aliases value objects directly, you encapsulate the logic and constraints. We do. But should we like construct the aliases value object inside of the constructor, or construct it outside and pass a reference to it? The skill entity shouldn't be responsible for validating or handling it. It's not. We already do that. There's the aliases. And there's a skill, and it basically passes the aliases. There we go. So we need to instantiate the aliases first, and then we need to pass it to the skill object. And we're going to basically use the skill object there. Okay, that works. Accepting primitives but transforming internally. This approach works but can couple the entity too tightly with the value object creation process, which may not always be desirable. Yeah, that was exactly what I was referring to. So that means we need to change the ID as well. The ID should be of type ID, right? Because right now it's an integer, but what if we decide to change it to a UID later on and, you know, ditch Snowflake IDs? We need to refactor this whole thing. But if we, you know, if we change the value object implementation, we won't have to. So yeah, very much so. In this case, it's going to be an ID that we accept from the value objects. It's going to be from the shared. And I'm not sure if we should pass super. There's another thing. This is a totally different thing. So we have an entity which has a value object, and we have a different class which accepts that from the arguments. Holy moly. This is complicated. Should we call it super? No, I don't think for the ID it should be the case. Because it also can be none. But it doesn't matter. No. I'm just gonna undo this. Technically, yeah, but I would rather keep it as an integer. Just because. Just because. If we still have some DDD experts in the chat, I would love to know your opinion on this. Should I keep using integer as a primitive value and then, you know, pass it on to the super constructor and have the, you know, super constructor construct the actual ID here? Or should I put it here? Because if I do that here, then this is self ID equals ID and that's it. There's not going to be any construction here, but the entity defines the ID and therefore defines the value object of the ID. So the entity should be the one that's constructing the value object, right? Because it defines itself, but not here. That's why I don't want to put ID here, because when we go to the, if we do that here, then we go to the entity, then this one is also defined as an ID, so no. Yeah, I'm gonna keep this as a primitive and let the base class, the entity class, handle the way that it constructs the value object and even like whatever the value object is. Cool. Okay, so there we go. And now we just need to get these two, but they're not gonna be like this. They're going to be add, and they're going to be remove. That's it. We're going to invoke these two methods, add and also remove. And whatever they do, if they raise a value, they raise a value. That's it. We just need to basically pass that here. And if there are any like checks, they should be here. Validation checks. Like for example, a skill can only have 10 aliases max. So when we do this, that's when we do check length, right? Yeah. So far, that's it. Maybe we also need to do the length class. Is it? No. Or it's actually return length of self.aliases. If it says, I always pass the ID that I create outside of the entity's aggregates inside the command handlers because of testing reasons. I do TDD, so I want to have the control on the ID generation by passing fake implementation. Right, yeah. That's gonna be another thing. We still didn't even, you know, start writing any tests. So that is such a good point, yeah. So when we want to test the, not the command handlers, but the entities, we definitely need to pass. I mean, we can still pass them, right? We have the ID here. There is a way to pass predefined values instead of letting them generate them. Yeah, to test that something that can be, that is random can be hard. That's definitely the case. Okay, we also have the length method. Yeah, for this, I guess I'm just gonna leave it. If it's nested, it's way harder, definitely. But I guess I'm just gonna leave it as a primitive now, because at least in testing, when we want to create a new skill and, you know, pass a fixed ID that we predefine in the tests, that's gonna be possible. It's just gonna be an integer. The types are gonna be different, but the opportunity is there. Okay, cool. And we also have the match method here, but I have no idea what that does or why we have. It's basically a keyword. Oh yeah, if a skill matches, if like a string matches a skill, that's what we're doing here. What is that? What is that? Okay, so aside from add and remove, we definitely want to expose the contains, right? So that we can do the match here. Oh, not do not deleted, but like uncommented, and or self.aliases contains that keyword. And this is basically like if when we, and you don't really see this, but it's basically what it says. Self.aliases.contains keyword. Basically when we parse the resumes, like PDF resumes, PDF uploads, when we do that, or when we, you know, get the user input, we're just going to like we'll basically try to match if this skill matches that keyword. This is a really too early to implement this method, but you know, we just added it just so we can have something. There's definitely going to be a lot of refactoring later on, but yeah, so far so good. Okay, so now we have the skill, like the whole skill, and we can actually try this out. We can try to create a skill, don't pass an ID, and pass like some aliases in there. And the aliases can be from a string, which is the three pipe. Let me actually clean this up. The three pipe delimiter. So let's see, from skill, domain, entities. Actually, there's no entity. We're looking at the aggregate roots here. Aggregate root, you're going to import the skill class, and also from skill domain value objects dot aliases, import aliases. And now we want to, hold on a second, we also need to update the ID and then also say aliases as an array, and then pass self.aliases. Yeah, and then the string method is going to be, that's a string. I actually need the representation method as well, right? Because this is just for printing. I don't want to see triple pipes for printing, so I'm just going to return comma, I guess, dot join self aliases. So like it's just better for debugging, so we can see all the aliases, but we're gonna use the string to. Now in this case, what's going to be used if I just pass this to a string and you don't see it, but if I pass self.aliases here as part of this string, then this is gonna be used. This is not gonna be used. This is gonna be used when I create the aliases, and if I just like mention it in the REPL, this is gonna be used. But this is going to be here, which is the representation of the skill. Okay, let's just see what happens. Let's just see what happens. I need to get out first. And now import aliases, import skill. And we're gonna print out a skill where the label is react.js and the aliases are going to be an aliases instance. Actually, not aliases, from string. And we're going to do react triple pipe, lowercase react, or react.js with a space, right? That's it. There we go. So skill is react.js and the ID is there. The ID is there, but where is the... Oh, that's the representation, of course. Hey, hold on a second. We have the ID there, but do I need to do this again? Come on. Import skill, import aliases, and now try to do this thing again. There we go. Okay, yeah, it's the triple pipe what's used because we literally use it inside of a string. So the skill is React.js, the ID is a Snowflake ID, and the alias is a list of React.js with a space, React lowercase, and also React without the JS uppercase. Okay, so far so good, but we know that this is not being, this is being used in the representation, not this one, because it doesn't know, it's literally in a string. So I'm just gonna remove this, and cool, all happy, all good. What is this now? Value objects plus skills plus aliases, whatever that means. And yeah, you can reload on the package name in the REPL. How can I can do that, like Python 3 and do, no, not reload. Like this. But I also need to define the import lib. So far it was like easier if I just, restarted the REPL. But I need to look into that. Definitely need to look into that for like more complex REPL sessions. All right, we have 15 minutes left. Still no unit tests, unfortunately. But we did define a lot of things. We defined the base classes for value objects and entities, which is, I guess, everything that we need. For the domain, at least. We're gonna work on commands and stuff like that later on. But yeah, cool stuff, right? We created the root aggregate, which is the skill. Yeah, definitely. We should have done that. Should have started with that. REPL was like, oh, let me just try this quick, and then it, became, we got used to it. I got used to it. But yeah, next stream, let me write this down. Actually, yeah, let me write this down. Monday stream. I'll tell you why I blocked when I say let me write this down, actually. For the Monday stream, unit tests. Unit tests with like very large letters, unit tests. We gotta do unit tests, okay? Unit tests for the next stream. But yeah, we got the entities. We figured out the value objects. We figured out like what's the role of value objects as well. We learned that inside of the root aggregate, we do all of the commands there. For example, for skill, we also had aliases, but in order to add an alias to a skill, you go through the root aggregate. And when we get to the users and profiles and positions, that was like 2 levels nested of value objects. Everything's gonna go through the user, right? So the user is gonna be like this object that manipulates every nested entity and value object that's like within itself, right? So that was the rule. That was the role of root aggregates. And basically, they're still entities, but they're entities that have some special responsibilities. At first, I thought there was a root aggregate and there was an entity, and I created 2 files, one for the root aggregate and one for the skill entity. But no, there's like the same thing. There's one entity that is, you know, the root aggregate. Yeah. Tests are the main thing that'll prove the usefulness of all this architecture. Definitely. So for the next stream, we're going to go and look into unit tests, because I think we did enough of stuff, you know, now like in terms of value objects and stuff like that. So now, since we have this code, we can actually set up unit tests. And moving on, we'll try to write the unit tests first, and then implement the rest of the entities and value objects and etc. So yeah, just so we can get our feet wet, we did this first aggregate like this. But from now on, let's try TDD. Let's actually try TDD. Now, again, yeah, Monday at the same time, we're going to continue this. For now, I actually want to show you what I got and why I blocked when I said, should I write this down? Yeah, no more tech talking. Let's check out some cool stuff. This is a really niche thing. It is a fountain pen. And I got this one yesterday. And I had one like this. It was more expensive and and much heavier. Uncle Lazar. And I lost it. I was at a local event, a tech meetup here in Toronto, and I lost it. And I ordered a different pen, because I like pens. I like fountain pens. As you can see, right now I'm punishing myself and using this like cheap. You see, like a cheap Amazon fountain pen. But those days are done. Your dad collects pens like Mont Blanc. Those are really expensive. I don't even collect them. I had this one thing, and it was like steel pen. Indestructible. But you can lose it. That's what I did. That's why I only have the cap of it, just to remind me, you know, you lost $100 plus pen. But this one is not steel. This one is aluminum. They gave me a sticker, a little history from the company. That's like from 1883. So this is like a pretty old company. Really cool. And the pen itself. Let's check it out. Okay. It's not heavy at all. That other one was like, I think 50 grams or something like this. All right, this is the pen. It is. Let's see if we can focus on this. Yeah, we actually can't. There we go. Aluminum Kaweco pen. That is like, of course, self-refillable, but really nice. Really nice. You got some unboxing content. How do you like this? Check this out. All right, I'm actually gonna fill it up now, and I'll try to use it and see how it writes. This one has a fine nib. Like and subscribe, please. This one has a fine nib. I used to use a medium nib, and it was crazy. It was gushing ink. But yeah, here's the cartridge. This is called the cartridge, and this is where you put the ink in. And it has like a little ball bearing at the top. So when you add it, you basically puncture that and you don't see this. But yeah, that's how ink flows. And when you actually finish the cartridge, show one pen by video and you may be contacted for a collab. Might as well. These things are expensive. If companies send me these for free, I'm gonna become a millionaire from the pens, not from the AI project that we're building here. But yeah, this is the cartridge. I do have a blunt needle syringe and like a larger ink bottle that, you know, I can just like get some ink and like inject it into this little cartridge. But yeah, so far we have a blue ink that comes from the company itself. So I just need to like push this in. There it is. So now it's in and I just need to close it. And there it is, and put the cap on. The cap doesn't twist. When it's posted, it twists when you like close it. So there we go. Now it's loaded, and I'm gonna try to write some stuff. I think there was like a thing that you should do to like get the nibs, optimize the nibs. Yeah. Let's see. Unit tests for the Monday stream, and I'm going to write be happy. Really good. Really good. This is how it writes. There we go. Be happy. All right. So yeah, I have a new pen. Really cool aluminum. It is lighter than, you know, definitely lighter than the previous one, so I'm gonna miss the weight a little bit, but I'm still happy with this. Yeah, this is it. I mean, the camera doesn't do it justice. Like, it is really, let's see, check this out at the top there. There's like a little logo of the company. Really cool. Can't focus on it, it's like too small. But yeah, I like this. I like these pens. I'm not a collector, but might as well start collecting them. I would have had a second one if I didn't lose the first one, but you know, what can you do? What can you do? All right, yeah. From this point on, I'm going to be using this to write my streaming notes. And cool. Yeah, that's it. This is it. That's it for today's stream. I think I can feel like we're on the right track. We're definitely on the right track. Let's do some unit testing in the next stream, and you know, try to do proper TDD from Monday on, because I want to do that too. I want to like try to build a project with TDD, at least on the backend side. React, I don't know. We'll see. But yeah, thanks for watching, everyone. This has been a really cool episode. Have a great weekend, and I'm gonna see you all on Monday at the same time. All right, take care. Bye.